Hi everyone, I'm Mogubobi2. In this lesson, we will officially create the main character asset for the animated project Hattie, walking through the entire pipeline from modeling, texturing, rigging, and lookdev to the final publishing. This process not only covers the core workflows of the asset department, but also highlights Blender's advantages in data structure design and team collaboration efficiency. First, let's quickly take a look at the file structure during the asset creation phase. In the project, all assets are stored centrally in the Assets folder and named after the asset itself. Each asset directory contains multiple subfolders corresponding to different production stages like modeling, texturing, rigging, and lookdev. Additionally, there is a dedicated publish folder used to store asset data that can be directly referenced by shot files. With the file structure clear, we can follow the production pipeline to see how an asset is built step by step. Step 1 is modeling. Starting from the modeling phase, based on early concept sketches, we first sculpt the main character's blockout in Blender, and then perform retopology. Once done, we clearly name the body mesh and groom mesh separately and organize them into their corresponding collection structures, wrapping them in a unified root collection for overall management of this character asset. When the model file structure is organized, it can be sent down the pipeline for texturing and rigging. Step 2 is texturing, which we choose to complete in Substance Painter. First, we export the model as an FBX file and import it into Substance Painter for texture painting. Once painting is finished, we export the texture resources for the subsequent lookdev phase. Step 3 is rigging. In this phase, we use Blender's built-in Rigify add-on. After opening the rigging file, we import the models collection into the current file by appending it. We do not use linking here, because rigging requires direct manipulation of the model's data blocks, as mentioned in the second lesson, such as vertex groups and shape keys, which currently cannot be modified across files via library overrides. After generating the armature and binding the weights, we organize the newly generated armature and controllers under the model collection, clean up unnecessary objects, and save the file to complete the rigging phase. Step 4 is material creation, also known as lookdev. This is an extremely flexible stage in the Blender workflow, and one that best demonstrates the advantages of data reusability. In the lookdev file, we append the model and groom collections to complete the material creation and assignment. Once lookdev is complete, we save a copy of the current file and name it latest. This latest file will serve as the live source for the asset's material appearance, to be referenced universally by the publish file and downstream shots. The biggest advantage of this naming and referencing method is that updating the latest file just once automatically syncs the newest material effects across all publish and shot files using this asset, without needing manual replacements. Step 5 is asset publishing. In this stage, we assemble the results from all previous stages to generate a publish file that can be directly used by shots. First, we open a new file and append the completed character collection from the rigging phase, and then link the character collection from the lookdev latest file. Next, we run a script to transfer the material data from the linked object to the rigged object, completing the final material assembly. Once verified, we can delete the linked collection and purge any unused data. To make the asset more flexible in shots, we need to design some controllable parameters in advance. For properties that cannot be directly modified via library overrides, we can use custom properties to convert them into dynamically controllable parameters per shot or project file. My production habit is to place an empty object as a controller in the outermost collection of the asset, and constrain it to the asset itself. All custom properties are created on this empty object. In this project, I created parameters to toggle groom visibility and control the viewport display density. Once these custom properties are connected to their respective data via drivers, we can adjust these parameters using library overrides in the shot files, thereby indirectly controlling data that natively cannot be overridden. This way, we can completely turn off the groom during animation and toggle it back on at any time during lighting to preview the final look. After completing all these steps, we can save the final publish file. This published asset is highly flexible and reusable. When an asset needs modification, you can simply adjust the published file directly without needing to reassemble the asset from scratch. Meanwhile, lookdev remains completely independent, allowing you to tweak materials at any time, pass down different material versions, or even adjust parameters on a per-shot basis, dramatically increasing overall production efficiency. That wraps up the entire creation pipeline for the main character asset. In the next lesson, we will cover the pipeline for environment set assets and finish up the remaining key assets. See you in the next lesson.